Download this code from codegive.com, link in the description below. OK, let's dive into creating a basic, almost plug-and-play Digipeater using Baofeng radios. I'll emphasize the limitations up front, offer several approaches, and give a code example for the most practical method. Disclaimer: this is an advanced project that involves potentially modifying your radio, and assumes you have a basic understanding of amateur radio, APRS, and programming. Always adhere to local regulations regarding amateur radio operation and licensing. Be aware that improper configuration or operation can interfere with other services and could result in legal penalties. The use of Baofeng radios as a Digipeater is often a compromise. Dedicated APRS radios are usually more reliable and feature-rich. Important limitations of Baofeng Digipeaters. Before you get too excited, understand the inherent challenges. No true full duplex. Baofeng radios are primarily half-duplex. While you can often monitor a frequency while transmitting, they aren't designed for simultaneous transmit and receive like a true repeater. This affects performance significantly in a Digipeater setup. You can work around this by using two radios. No true dual watch. Baofeng dual watch is a scanning feature, not simultaneous reception. The radio constantly switches between the two frequencies, but it's not receiving both at the same time. This means packets can be missed if they arrive on one frequency while the radio is listening to the other. Poor front-end selectivity. Baofeng radios are known for having relatively wide receive filters. This can make them susceptible to interference from strong signals on nearby frequencies. Inconsistent deviation and tones. Achieving consistent and accurate AFSK tones, necessary for APRS, can be difficult. This can reduce reliability. Duty cycle limitations. Continuous transmission can overheat the radios, especially at higher power settings. Duty cycle limitations are critical for stability. No native APRS support. Baofeng radios don't have built-in APRS functionality. We're essentially faking it with external hardware and software. Understanding APRS Digipeaters. A Digipeater, short for digital repeater, is a radio station that receives APRS, automatic packet reporting system, packets and retransmits them. This extends the range of APRS transmissions, allowing users to be tracked and messages to be delivered over a wider area. The basic function of a Digipeater is 1. Receive * listen for APRS packets on a designated frequency, typically 144.390 MHz in North America. 2. Decode * interpret the digital data within the packet. 3. Retransmit * broadcast the packet again, ideally with a changed path so packets don't loop indefinitely. Hardware components. You'll need the following. Baofeng radios. 2 radios are highly recommended. UV5R, BFF8HP, or similar models are common. Raspberry Pi, or similar single-board computer. This will act as the brains of the Digipeater, handling decoding, packet construction, and timing. A Raspberry Pi 0W is often sufficient for a basic Digipeater. USB sound card, optional but recommended. Using external USB sound cards can isolate the audio and prevent ground loops. TTL serial to USB adapter. This may be needed for radio control. Interface cables. Custom cables to connect the audio outputs of the radios to the Raspberry Pi's sound card, and the audio output of the Pi to the microphone inputs of the radio, These must be properly shielded. You may want to use isolation transformers in the audio paths. Antenna, a decent antenna is essential. An external antenna will always outperform the stock antenna. Use an antenna appropriate for the 2-meter band, 144 to 148 MHz. Asterisk power supply asterisk a stable power supply for the Raspberry Pi. Asterisk enclosure, optional a weatherproof enclosure is recommended if you plan to deploy the Digipeater outdoors. Asterisk resistors asterisk to attenuate the audio signal levels to the appropriate levels for the Baofeng. Baofeng radios are notorious for having sensitive microphone inputs. Asterisk isolation transformer asterisk can prevent ground loops and help eliminate noise. Software setup, Raspberry Pi. 1. Install Raspberry Pi OS asterisk download and install the latest version of Raspberry Pi OS, formerly Raspbian, onto your Raspberry Pi's SD card. Use the Raspberry Pi Imager tool for the easiest setup. A light version is typically sufficient, as you won't need a graphical desktop. To enable SSH asterisk before booting the Pi for the first time, enable SSH so you can access it remotely. Create an empty file named SSH, no extension, on the boot partition of the SD card. 3. Boot and connect asterisk insert the SD card into the Raspberry Pi, connect it to your network, via Ethernet or Wi-Fi, and power it on. Find its IP address on your network, usually through your router's admin interface. 4. SSH into the Pi asterisk use an SSH client, like PUTTY on Windows or the SSH command on Mac OS/Linux, to connect to the Raspberry Pi. The default password is Raspberry. Change this password immediately after logging in for the first time. Use the password command. 5. Update and upgrade asterisk run the following commands to update the package lists and upgrade installed packages. 6. Install APRS software asterisk there are several options for APRS software. We'll use Direwolf, which is a versatile and widely used software modem/encoder/decoder for APRS. 7. Configure audio asterisk edit the /etc/asound.conf file to configure the sound card. If you're using the built-in audio, it's usually card 0. If you're using USB sound cards, identify their card numbers using a play L and a record L. Configure asound.conf something like this. You will need to configure the transmit audio separately, or combine the configuration. Important asterisk setting the correct sound card numbers is crucial. Incorrect settings will prevent Direwolf from accessing the audio devices. 8. Configure Direwolf asterisk create or edit the direwolf.conf file, usually located in /home/pi, to configure Direwolf. Here's a basic configuration example. Explanation asterisk. Asterisk mycall, replace mycall1 with your call sign and SSID, example W1ABC10 for a Digipeater. The SSID is important to identify the Digipeater uniquely. Asterisk a device, specifies the audio input and output devices. This is where you'll configure the sound cards. If you only have one sound card, you'll need to use it for both receive and transmit, which can be tricky. Plug how 2,0 is an example for USB audio card 2. Asterisk PTT, if you can use the serial port for PTT, this will be a great advantage. Otherwise, you can use Vox, but will probably need a separate sound card for transmit. Asterisk modem, sets the modem type to 1200 baud AFSK, which is the standard for APRS. Asterisk KISS port, enables the KISS TCP port, which allows other programs to connect to Direwolf for APRS data. Asterisk Digipeater 1, enables the Digipeater function. Asterisk DG_path, extremely important, this sets the Digipeater path. Do not use wide 1-1 wide 2-1 unless you fully understand the implications. Using a path like this can easily cause loops and disrupt the APRS network. Wide 1-1 is generally safer, but still use it with caution. Consider only using paths for stations you hear regularly to limit loops. You can also set the max_age in direwolf.conf to limit the age of packets that you will digipeat. 9. Run direwolf * start direwolf from the command line. Watch the output. You should see direwolf initializing the audio devices and attempting to decode APRS packets. If you see errors, double-check your configuration. 10. Test the Digipeater * send an APRS packet from another station, or use a handheld with APRS functionality, to test the Digipeater. Monitor the output of direwolf to see if it's receiving and retransmitting the packets. You will need to use a second Baofeng, or dedicated APRS transmitter, to send the APRS packet from the Raspberry Pi. 11. Configure auto start * to make direwolf start automatically on boot. Add it to the /etc/rc.local file, before the exit 0 line. Note *rc.local may not be enabled by default on newer versions of Raspberry Pi OS. If it doesn't exist, you'll need to create it and make it executable. Add this line before exit 0. Make sure the file is executable. Radio configuration. 1. Frequency * program both radios to the APRS frequency, 144.390 MHz in North America. 2. CTCSS/DCS * disable CTCSS/DCS tones on both radios. APRS uses data, not tones. 3. Squelch * set the squelch to the lowest possible setting where you don't hear constant noise. You want the radio to open the squelch reliably for even weak APRS signals. 4. Power * start with the lowest power setting. Increase it only if necessary to achieve reliable coverage, bearing in mind the duty cycle limitations. 5. Microphone gain * adjust the audio output level from the Raspberry Pi to the Baofeng's microphone input very carefully. Baofeng radios have extremely sensitive microphone inputs. You'll likely need to use a voltage divider, resistors, to attenuate the signal significantly. Overdriving the microphone input will result in distorted AFSK tones, which won't be decoded properly. 6. Vox versus PTT * if you can control the PTT using serial commands, great. Otherwise, you'll need to rely on Vox, voice-operated exchange. Enable Vox on the transmit radio. Adjust the Vox sensitivity so that it reliably activates when direwolf transmits audio, but doesn't trigger on background noise. Cable construction. This is where it gets hands-on. You'll need to create custom cables to connect the audio outputs of the Raspberry Pi to the microphone inputs of the Baofeng radios. 1. Identify connections * determine the pinout of the Baofeng's accessory connector, usually a Kenwood-style 2-pin connector. You'll need to connect ground and the microphone input. 2. Audio attenuation * use a voltage divider, 2 resistors, to reduce the audio level from the Raspberry Pi to a safe level for the Baofeng's microphone input. Start with a high attenuation ratio, example 10:1 or even higher, and gradually increase the audio level until you get reliable transmission without distortion. 3. Shielding * use shielded cable to minimize noise pickup. 4. Isolation transformer. Recommended an isolation transformer in the audio path can help eliminate ground loops and reduce noise. Code example, basic Python PTT control, requires Pi serial. This example assumes you have a USB serial adapter connected to the Baofeng radio and can control the PTT line by asserting /deasserting the DTR or RTS signal. This requires the radio to be modified internally. Important notes about the Python code ***. Asterisk requires pyserial *** install it with pip install pyserial. Asterisk replace /dev/tty USB 0 asterisk with the correct serial port for your USB serial adapter. Asterisk replace ptt_pin asterisk choose DTR or RTS depending on how your serial adapter and radio are wired. Asterisk audio transmission asterisk this example only toggles the PTT. It does not send audio. You'll need to integrate audio playback using libraries like PyAudio or by calling external commands like aplay. You would generate the audio stream with direwolf and pipe the audio to aplay. Asterisk timing asterisk adjust the time.sleep values to suit your radio and the duration of your audio transmissions. Asterisk error handling asterisk add more robust error handling. Asterisk this code is just an illustration. Do not use it directly in a Digipeater without proper testing and adjustments. Tips for success. Asterisk start simple asterisk begin with a minimal configuration and gradually add complexity. Get basic receive and decode working before enabling digipeating. Asterisk monitor the APRS network asterisk use an APRS client, like APRSys/32 or APRS Droid, to monitor the APRS network and see if your Digipeater is working correctly. Asterisk use a good antenna asterisk a properly tuned external antenna will significantly improve performance. Asterisk minimize interference asterisk keep the Digipeater away from sources of interference, computers, power supplies, etc. Asterisk proper grounding asterisk ensure all equipment is properly grounded to prevent ground loops. Asterisk monitor temperature asterisk keep an eye on the temperature of the radios, especially if they're in an enclosure. Add cooling if necessary. Asterisk document everything asterisk keep detailed records of your configuration, cabling, and testing. This will make troubleshooting much easier. Asterisk test, thoroughly test the Digipeater before deploying it in a public location. Asterisk be a responsible operator asterisk monitor the APRS network for loops or excessive traffic and adjust your Digipeater configuration accordingly. If you see a problem, shut it down immediately. Asterisk update direwolf asterisk keep direwolf updated to the latest version. Asterisk consider legal ramifications asterisk you may need permission from local authorities to operate a Digipeater. Always operate within the regulations of your amateur radio license. Asterisk use APRSs as a fallback if you cannot achieve consistent results, you can feed APRS information to and from the internet. Alternative approaches. Asterisk dedicated APRS radios asterisk if you're serious about APRS digipeating, invest in dedicated APRS radios like those from Kenwood, Yaesu, or ICOM. These radios are designed for APRS operation and offer superior performance and reliability. Asterisk TNC, Terminal Node Controller. A TNC is a hardware modem that handles APRS encoding and decoding. You can connect a TNC to a standard radio and use it as a Digipeater. TNCs are generally more reliable than software-based modems. Conclusion. Building a Digipeater using Baofeng radios is challenging but possible. By understanding the limitations of the equipment, carefully configuring the software, and taking appropriate precautions, you can create a basic Digipeater that extends the range of APRS communications in your area. However, be prepared to troubleshoot and experiment, and always prioritize responsible operation and adherence to regulations. Good luck, and have fun.